Good morning. Let's see if this works. Yeah, okay. So, this morning we're going to talk a bit about asynchronous PHP, and it says the promise of asynchronous PHP. Why it says that will become clear throughout the talk. Let me quickly start by introducing myself. My name is Wim Godden. I'm from Belgium. That's not far away. I guess everybody here knows where that is. Best known for beer, of course, and chocolate and other tasty, yummy things. And old buildings, of course. It's funny that we're in an abbey. In my town, we also have a very nice abbey from the 13th century and a couple of castles and stuff like that. Sadly, not all good news in Belgium. We also have that little issue of traffic. This is what happens when we get some snow. And smack in the middle of that, I started a company 15 years ago called Cube Solutions. Yes, we do have that fancy URL, spelled out Cube. I've been doing open source since around 1997, mostly PHP, but also quite a lot of work on Nginx and other stuff. And I've worked on projects such as OpenX, the advertising project, and I wrote PHP compatibility and PHP consistent and a few other tools. And I've been doing talks like these for the last couple of years. That's enough about me. Let's see who you are. Who here is a developer? I guess most of you, yes. Who's ever worked with any asynchronous PHP libraries? A few, okay. Anyone work with Node.js? I'm sorry. Okay, so we're going to talk about asynchronous processing, which means we have to talk about what synchronous processing is as well. So in synchronous processing, let's imagine we order something on a website, then obviously we need to do quite a few things to get that order in the system and get it processed and then send some kind of confirmation to the user. So in this example, we will insert an order, then we will check if the payment has been made, then we will update the payment and maybe update the stock information, then we will send some kind of API call to Federal Express or UPS to get it shipped. Finally, we'll send out a confirmation mail, and then we will display to the user, thank you for your order. Now this entire process, if we do it synchronously or sequentially, it's going to take 3 seconds. Now we don't want our user to wait for 3 seconds. We would rather have him wait for like a second, maybe 1.5 seconds, and then display, thank you for your order. Now the only way to do that is to make sure that we can process some of these things simultaneously. So, for example, we could update the payment and stock information at the same time as calling the API to Federal Express or UPS and sending out a confirmation mail. If we could do that simultaneously, that would be great. Now in normal PHP code, that's a little tricky because you run from A to Z in PHP. You can't actually tell it, do something else in the meantime, unless you start using things like queuing systems like Gearman. But luckily, asynchronous processing will allow you to do that. Now, why doesn't PHP allow you to do this out of the box with standard code? Well, because each of these things is basically what we call a blocking process. It's blocking I/O, which means if you're reading from a disk or if you're writing to a disk, you're actually telling the disk, please send me this information, and then PHP will wait for it. It will wait for that data to come back. Same thing with the network, same thing with the database communication. With a few exceptions like PostgreSQL, for example, you can do asynchronous calls. You can tell Postgres, fetch me this data and I will come and pick it up sometime in the future, I don't know when yet. Sending mail, same thing. It will wait for the mail server to say, okay, I sent the mail out. And if that takes 10 seconds, then your user is going to have to wait 10 seconds. So non-blocking stuff is very good because it means you can work on more than one thing at the same time. And you get rid of that sequential situation, partially of course, because you still are processing things sequentially, but at least you can tell it to go out and do stuff while you're doing other stuff in the meantime. The big question is, how do you know that when you tell PHP, go and process this thing, how do you know when it's finished? And the only way to do that is through events. So your asynchronous call is going to send an event and say, okay, I'm at this status. And there's a couple of standard ones. One event is, of course, hey, I started working. There's a progress update usually. And then there's two that will indicate I finished, either successfully or with a failure. Now, for those of you who use Node.js, you might recognize this kind of structure. It's called callback hell. This looks pretty nice still. Usually it's like 20 levels deeper, and it's not very easy to understand what the heck is going on, especially not if there's a lot more code in there. This is what we don't want to see, of course. We want to have our code readable as possible. So in PHP, luckily, there's a couple of libraries that allow you to write way more readable code than this. Okay, so let's have a look at where we are in PHP. PHP has a couple of built-in functions that actually allow you to do a lot of asynchronous processing. You don't have to go elsewhere. It's built into PHP. You don't have to install any special additional libraries or link to some kind of external service. Most of it is built in. It's just that most people don't realize that it's built in. There's a couple of libraries, PHP-based libraries, that use those built-in functions. And I'll discuss one of them a little bit more extensively, which is ReactPHP. Who's ever heard of React? A few people, okay. So I'll give a few examples of ReactPHP code and how that works, because it's the one that most people would start using. There's also the alternative Facebook hack, which has an async implementation. I'm not going to go into that one. I'm not an expert on Facebook hack. But if you are using HHVM and by extension Facebook hack, then it's built in to Facebook hack by default. So let's look at a couple of those built-in functions and a couple of those libraries to give you an idea of what PHP is capable of in terms of asynchronous processing. So the first one is Pthreads. That's built into the core. It does require you to install the thread-safe implementation of PHP, which is not available in every single installation or every package manager. It is a PECL extension, so it should work on Linux, it should work on Windows as well. And it allows you to do multi-threading. That means it will not allow you to do multi-processing, so it will not actually run on more than one core. So if your PHP process starts on one CPU core, then all the threads that it launches will run on that same CPU core. So it will not use the full potential of your machine. So if we look at a basic implementation, let's say we have a class web request that we create, and we have the Pthreads PECL extension loaded, then we can just extend thread. Thread is then a class of that extension. And here we have a constructor where we set URL, and there's a public method here called run, which will automatically be called. And in this case, it's just going to do file get contents. Now, if we were to run file get contents on, let's say, a big file of 100 megabytes, that could take a few seconds. We don't want our user to wait those few seconds, so we put this in basically in an asynchronous process. And then we can just say, okay, I'm going to create a new web request. I want that URL to be requested, and I'm going to start that request. Now, as soon as you do this, it's actually going to start that run method, and it's going to do that in the background. So whatever we do after this, we can do whatever we want here. In this case, I'm doing array fill 10 million times test. I'm filling an array with 10 million items of nothing more than the string test. And I'm going to do a for loop across that. Basically, we can do whatever we want here. In the background, in the meantime, that file get contents is running simultaneously. Once we are finished doing whatever we want and we want to check on did it actually complete, we can just say request join. And then it's either it's going to wait for the file get contents to finish, so it's going to block here, or if the file get contents already finished, it's just going to continue immediately. And then we can just get the response from that object. So this is a very simple way built into PHP to process certain things in an asynchronous way. It doesn't work for everything. There are certain things that will remain blocking, but this works for most of the things out there. The second way is using PCNTL fork. This is one that will actually clone your PHP process. So your PHP process is running, and it will actually make a copy of it. So it will actually run it in a separate process ID, basically. This doesn't support multi-threading. It does support multiprocessing. So it's going to launch a new process which can run on a different core. The issue is that it says no communication between processes. You can return stuff from it, but you cannot communicate in the other direction. You cannot say, okay, handle this bit of code, handle this piece of information, do something with it, and then midway through the process you cannot say, oh yeah, and also do this, or stop working now. You cannot do that. So it's going to go off and just run completely. And it doesn't work under Apache, which might be an issue if you're still using Apache. So the third one is popen. So let's say we have a child.php and we do some work. In this case, we just echo something. But it could be a lot more, could be very hard work, could take 10 seconds. Doesn't really matter what it is. Then in our main.php, what we can do is just say popen, and then we run php child.php. This is basically just going to launch a process that's going to run child.php. Then we can do whatever work we want to do, and at the end we can just say stream get contents, and we get the output back. This is another way of doing asynchronous processing. However, there's a big red warning there, maybe not as big as it should be. It doesn't do the same thing on every single operating system. So I don't recommend using this at all. But it's out there, it's possible. Many web hosting providers will block this, by the way. Now, a lot of people want asynchronous processing to do stuff like request contents from 10 URLs at the same time. Because you don't want to, for some reason you need to fetch 10 web pages. You don't want to fetch the first one, then the second one, then the third one. Because if one of those is extremely slow, your visitor is going to wait a long time. So you might want to fetch 10 of those at the same time. And that's perfectly possible with something like curl multi-select. It's built into PHP. You don't have to add anything except for the curl extension, of course. Now this code may be a bit small at the back. I'm sorry about that, but I had to fit it on one slide. So basically in this case we're going to fetch 2 URLs. We're going to create 2 curl objects or resources. We're going to set the URL. We're going to init those. And then we're going to add them to a multi-handle. And then this is a lot of complicated code to get around a curl bug actually. But basically we're going to fetch all that information, and there's a micro sleep in there to get around that bug. Otherwise it would do weird stuff. But basically this is, I wouldn't say this is simple code anymore, but this is relatively easy code to fetch multiple URLs at the same time. And that's a big advantage as opposed to fetching one after the other, of course. There is one method that I'm going to mention, and I really advise you not to use it. But I want to mention it because a lot of people would use it. It's using curl as the asynchronous process system. So basically imagine that you have 5 items in your entire process that you need to do. 5 processes that need to run. Some calculation, inserting something in the database, and a few other things. Then one of the things you might think is, hang on, if I just put them in 5 different files, and I just make a request to those 5 files from my main file, then it's fixed, So you could do something like this. You could say, in my main process, I'm going to open this very long process that's going to run for 20 seconds. And I'm going to say, I have a timeout of 1 millisecond. And I'm just going to do curl exec, which is going to call that URL, and immediately say curl close, which means this code will continue after 1 millisecond. And the PHP process on the other end, yeah, that's probably going to continue running, usually. But this is not really the ideal way. This is not really a safe way of doing it, because you have no control. If you're calling 3 of these URLs, you have no control over the order of those URLs in which they're being called and in which everything's being processed. And actually, you're just saying, call it, and I don't care about the result. So you don't even know if the result was successful of that call. So I don't advise you to do anything like this in any case. So there's a couple of underlying libraries that take care of event handling. There's libevent, libev, and libuv. They're going from old to newer to the newest library. They are PHP extensions. They rely usually on the libraries that you can install on Linux or on Windows. Libevent is the most famous one because it's being used by things like Memcached. libev is not available on Windows. Then again, libuv is available on Windows. So it's kind of weird. But basically, you don't need to worry about these. They are just being used by PHP and by a couple of the additional libraries built in. So I mentioned ReactPHP. This is probably the most used library for doing asynchronous processing in PHP. It's event-driven, and it provides all that non-blocking I/O, but it's actually not written in C. It's written purely in PHP. And so it builds on top of the existing functionality of PHP. So you can just go in there and look at how ReactPHP was written and make modifications if you want, make improvements on it. It's all based on the concept of the event loop. So it's going to start a loop and check if it needs to handle any events. If it does, then it's going to keep looping until it actually has handled all the events that it needs to handle. And then finally it's going to end. A very simple example of this is a simple web server. You can create a web server within PHP code that's written in ReactPHP that builds on asynchronous PHP libraries. First thing we do here is we create that event loop. So we just say new React event loop factory create. Now we have an event loop. Then we can create a socket that's going to listen on some port. We attach it to that loop. And ReactPHP has a lot of built-in functionality. One of them is a web server, an HTTP server. So we can just say, okay, I create a new HTTP server. I wanted to listen on that socket that I created, and I wanted to attach to that loop so that any events coming into the HTTP server are handled by the event loop. And then I'm just going to say, on request, so if I get an HTTP request, execute this piece of code. Well, in this case, what I'm just going to do is I'm going to write an HTTP header saying 200, okay, and then I'm going to send hello world. Finally, I tell the socket to listen on port 80, and then the last keyword is the most critical one here. If you don't do this one, nothing will happen. In this case, I will just say loop run, which is just going to start that event loop. And now we have a web server. Okay, it's not going to do much. It's just going to say hello world, I know, but it'll be a complete web server. So the structure of ReactPHP underneath is that event loop. That's the basis of everything. And so it's going to rely on things like stream select in the background, and then libevent and libev and libuv, whatever library you're using in that case. And then on top of that, we have a stream, like we had in the previous slide. In this case, we have a socket server, stuff like that, built on top of that. And then on top of that, you can have an HTTP server, for example, but it's not limited to HTTP. It could be an IRC server, or a WebSocket server, or even a DNS server is built in there. So you can handle DNS requests if you want. I wouldn't do it. It's not going to be as fast as a regular DNS, but you can. So ReactPHP is based on two, to understand ReactPHP, you need to understand two basic concepts. One of them is called deferred, and the other one is called promise, which is why there was that word promise in the title of the talk. Now, deferred refers to a computation that has to be executed. So let's imagine that I want to do a DNS lookup. Then the DNS lookup is the part that is going to be executed, and that's in deferred. That's going to be the name of that, basically, of the class. Deferred can have two statuses. Either it's resolved or it's rejected. Resolved means, yes, it passed, it executed. Rejected means something went wrong, I got an exception, I got a fatal error, whatever. So it completely failed. how that looks in code is actually very simple. So the thing you do is you say new React promise deferred. So basically you're saying, I'm going to do some action here. I'll show an example in code later of actual code. And then you have that deferred, you have that action that needs to be performed, whatever it is. And then you're just going to say, okay, I want you, dear action, I want you to promise me that once you finish running, then you do something. The first parameter here, this part, is what needs to be executed when it's resolved. So when whatever action had to be processed was successful. The second part is the failure part. This thing completely failed. Please do something on failure. And the third part is when there's a progress update. So if you have a very long process, you can actually say, okay, I'm 50% complete. At least you can show it to the user that there is progress. Even though it is an asynchronous processing, it's running, doing something completely different. You could have 10 of these and 10 of them providing status updates at the same time. So for example, in this case, you could have some class extending promise deferred, whatever it is. Show you an example in a minute. And whenever you do this, it will actually return either yes, successful, no, not successful, or status update. So let's look at a quick example. Is there anyone here working for a hosting provider? Nobody. Nobody working for a hosting provider. That's never happened before. Anyway, let's imagine that you want to look up host names somewhere. So you want your clients to be able to say, okay, I need hosting for www.google.com, facebook.com, and you want to be able to enter a gazillion host names in here. Now, we want to do a DNS lookup on that because we want to make sure that the host names that were entered were actually correct, were valid. But if we have, say, 100 of these, we're going to do a DNS lookup for the first, and then for the second, and for the third, and so on. That's going to take a long time. It would look a little like this in old-fashioned standard sequential synchronous code. So you would explode on the comma, and then you would filter out dangerous names maybe. And yeah, let's create an array that we're going to use later. And then we would do a for each across it, and then we would do get host by name to get the IP. Oh, and this is a funny one. The output of get host by name, if it cannot resolve it, is the host name again, which is kind of weird. So either you get the IP back, or you get the original host name back instead of false or something. So we're just going to check if it's different, then yes, it's an IP, and in this case, I'm just going to add it to success. And I'm going to echo out, you know, I had success resolving all of these hosts. Let's not worry about the errors right now. The async way looks a little, yeah, so the issue here is if you have a timeout on one host, then you're going to wait, you're going to wait, you're going to wait. The async way is a bit more code. So we're going to create that event loop. We always have to do that. And then we're going to use React DNS resolver. So it's even got a DNS resolver built in to ReactPHP. It's very big, and there's a lot of extensions for it. And we're going to give it a DNS server to use as the lookup. In this case, the Google DNS server, they're public, they're available, they're free, so we use that one. And we're going to do the same thing. We're going to explode those commas out and get all those host names. We're still going to loop over them. But in this case, we're going to say, oh, I have that DNS thing here. Please run resolve. This is our deferred, actually, on that host name here. And then, if you're finished, then please run this. In this case, I'm just going to say return host name and the IP. If you're not successful, well, in this case, I'm going to return nothing. I'm just going to ignore the error. This code, oh, yeah. So this code is going to run once for every single host name. Now, of course, the big question is, how do you know they're all finished? Because that's when you want to give output. So there's a simple extension for that to the promise thing. You can just say React promise. If all the promises that I created here are finished, then run another piece of code. And in this case, I'm just going to do something very ugly. I'm not going to get into that. And I'm just going to output the same thing. What you get with this code is you can run 10 DNS lookups, 100 DNS lookups simultaneously. Be careful if you run this on a DNS server and you're doing 1,000 DNS lookups simultaneously, then that might not work, of course. So there are ways of limiting how many asynchronous processes you can get simultaneously as well. Now, this then functionality that I showed, there is even a way of chaining those things. So in this example, we have a deferred, we say promise, and if you're finished doing whatever you need to do, then run a piece of code. I'm always going to return stuff. This return will be sent to the next then. The return here will be sent to the next then. So the output of resolve 1 is going to be, well, times 2, and it will output C as now 4. The same thing will happen if we get an error. So in this example, if we run resolve 10, it's going to say 10 is greater than 5. Oh, in that case, return A, return 10. But that's going to be returned right there, which is null. So that's going to do nothing, basically. However, if we run it with a parameter of 1, it's going to go in here, it's going to throw an exception. And so that's going to end up in the error part of the then function. And so we get this exception and then the message. So it's an easy way of handling errors as well, because the errors will go to the next then, will go to the next then. It's an easier way to handle all of that. Because you can't handle it in your main loop, because you're handling it in the part that's asynchronous right now. Now, ReactPHP, I showed you promises. They are very useful. They're quite easy to use, but they're kind of restricted because you always have to use that return. And yes, you can return objects and you can return arrays, but you can't actually communicate with whatever asynchronous processing was running. There is a concept of streams as well in ReactPHP, which is a lot more powerful. It is a bit more complicated for certain things, but the basic concepts are quite easy. Either a stream is readable, or it's writable, or it's both. In the case of both, a good example is a filter. You send something in and something comes out the other way. The only limit to what you can do is your imagination with these things. But I'll show you a quick example. So again, we have the event loop. We always have the event loop. And we create a stream that we're just going to read a file here. And we attach it to the loop. Then we have a filter. This is not in ReactPHP. This could be anything, any class that you want to use to filter. In this case, an alphanumeric filter. And then we have a destination, which is just we're going to write to a destination file. And now, for those of you who are used to shell scripting, we can just say source, so that file, pipe this through the filter, then pipe it to the destination. So take the source, send it to the filter, send it to the destination, and they will handle it automatically. So this is very useful. This is a very easy way of handling data without having to write extremely complicated things and still allowing you to do it in an asynchronous way. Because this file reading, this filtering, and this writing is all going to happen while you can do other stuff as well. Or you can do this 20 times at the same time for 20 files. Just don't stress your file system too much, of course. I want to give one final example of something you can do with ReactPHP. For those of you sitting at the back, it's going to be quite small to read because it's one big slide. We're going to build a chat client here in about 25 lines of code, and I mean a fully working functional chat client. So again, if you're sitting too far, come forward. Again, we have the event loop. We create a socket in this case that's going to listen on a certain port. I'm going to create an object storage. We'll get to that in a minute. And then I'm going to say, if I get a connection on that socket, then I want you to run some piece of code. I'm going to store a connection ID, and I'm going to output, please enter your nickname, because if we have a chat client, people connect to that port, then we want to recognize who they are. So they will just enter your nickname. And then I'm going to say, if I get on that connection, on data, so if I receive any data, then do something with whatever message I'm getting from the client. What am I going to do? Well, I'm first going to check if I have a nickname already. If I have a nickname already, I know who that is. If I don't have a nickname, then that person just typed his nickname. That's going to be whatever is in the message. So I'm going to set it. Otherwise, it's just a message. So all I have to do is look through my clients. If my client is the same as my current connection, well, I'm not going to send a message to myself. That's kind of stupid. And then I just output to the client this message. Finally, I attach my new connection to my clients. I tell it to listen on some port, and I run the event loop. This is an entire chat client written in PHP that you can just telnet to that port. It will say, enter your nickname, you enter your nickname, and then whatever you type next is going to be sent to the other people connected to that same location. We wrote a slightly bigger one with multi-channel support, and we actually use that as a communication system on our internal board. And it's very easy to write. It's a couple of lines of code, and 30 lines of code, and you can write an asynchronous thing that runs on one single PHP process. It doesn't use multiple processes, one per user or anything. It's just one process that runs an entire chat client. Chat server, I should say. Okay, so there's some golden rules that I want to mention and one quick warning about asynchronous PHP. So the first one is asynchronous processing does not mean that your code will be faster. In fact, in most cases, it will be slower because you have to build a bit more code to get the asynchronous stuff going. Because you're processing 10 things at the same time will not mean that it will run 10 times as fast. You can just do more than one thing at the same time, and instead of having blocking I/O every second or something, you can actually say, okay, I have blocking I/O somewhere, but when my process is blocking, I can do something else in the meantime. So the end result will be that the process from A to Z will be finished sooner, but you will still use at least the same amount of CPU power. Also, don't assume that your code will remain just as fast. Like in the beginning, I said you can have an API call to UPS or Federal Express. Maybe that call today takes only half a second, but you're still doing it asynchronously because you don't want to wait for it. But in the end, if you do 5 things asynchronously, you have to take a look at the slowest one. If that takes 10 seconds, then your user is still going to wait 10 seconds. Because at the end, you will wait for the longest one. So if you have something that takes half a second now, it might take 10 seconds next year. And then the whole thing will be slower. And this is one that's slightly attached to the previous one. If you don't actually need a response from that API immediately, then don't wait for one. Then put it in a queuing system like Gearman or any other queuing system that will run it afterwards, or even put it in a cron job, something like that. Don't wait for it to send output to the user. If the user doesn't need a tracking number for the shipment, well, send it later in an email. Tell them, thank you for your order, and we'll send you the tracking number in a few seconds. And this is a final warning. Asynchronous processing doesn't guarantee any execution order. So if you launch 10 different asynchronous processes, then PHP doesn't care about which one will be processed first. It's just going to pick up and run. So if you need one thing to happen first and then the other thing to happen next, then you cannot do it asynchronously. And with that, any questions?
Good morning. Yeah. Good morning. You talked about the async execution order. Isn't there any library to deal with it, like async in Node.js, for instance?
So there's Well, there are ways of handling execution order. In ReactPHP, I would have to look at it. By default, if you just launch it like the way I showed it here, it's not gonna care. Now, for example, of course, what you can do is within your asynchronous process, you can still define an order. But if you tell PHP to launch 3 different asynchronous processes, it's not going to care about which one will be handled first. There are certain ways of saying, okay, you need to do this first, and then you need to launch that. In ReactPHP, the way to handle that is using the then statement, because it will chain automatically. I don't know in other libraries. I haven't used, there's quite a few of them now. They've been popping up like crazy for the last couple of years. So I don't know in other libraries how that works. The promise then is the proper way of doing it in ReactPHP.
Thanks.
Any other questions? Yeah.
Can you have a look to your code on a pipe, you know? Can you go
The one,
forward?
let's see.
Sorry.
This one?
Yeah, this one. You said we can do something during the processing of the file, but where can you put this code? Before the loop run?
Yeah, so for example,
what
what you can do is you can, here, you can actually attach other stuff to the loop as well.
Yeah, you attach something. Yeah.
Yeah. And this will actually start running as soon as it reaches the end of the line. This will already start running in a separate process.
Mm-hmm.
It's just not going to be, any events that this throws is not going to be handled until you have loop run, actually. But you can attach multiple things here and tell it to go and do other stuff, or have 20 lines like these underneath each other, and then it will handle all of those simultaneously.
Okay, then the processing starts at when we run the loop.
Yeah, the processing of any events that are handled there, I'm not sure, I would have to check if this will actually really start running immediately or if it will wait for the loop run. Mm-hmm. I would have to check on that.
Okay, thanks.
Anyone else? Oh, one more? Just go.
How do you handle exceptions and errors in async process?
Yeah, so every library is a bit different there. The way it happens in React is if you have an error of some kind, then it will actually trickle down to that to the rejected part of the then statement. So the second parameter of the then statement is actually what will be called.
Okay, so you have to, let's say if you send an email, it got an exception, you have the callback for reject, but you have to handle the logic to retry later, or I don't know.
Yeah, that's something you will have to do there.
Side, yeah.
Theoretically, what you could do there is, again, connect to the loop event handler and try the mail sending again.
Yeah, okay.
So you can launch asynchronous from, you can launch a new asynchronous process from within an asynchronous process, in theory. There's nothing preventing you from doing that.
Yeah, but you can't, like, if mandrill is down, you have to wait 5 minutes to retry the...
Yeah, then...
So you can't do that.
Yeah, then you're kind of stuck and you have to put it in a queue or something like that.
Yeah. Thank you.
Okay. I will put the slides on SlideShare. I'll send out a tweet, and I'll also link them on JoinedIn. Feel free to provide some feedback. It's always nice to hear what you liked and how I can improve the talk. Thank you.